with a real world example that makes the idea immediately obvious. Can two sets have nothing in common? Look at these two groups: Fuboti, Kofi, Ama, Kwame, and Yao. The chess club, you have Ifwa, Kweku, and Ajwa. Not one name appears in both. No student is in both groups. When two students share 0 common elements, we call them disjoint sets. Simple idea, but we need a precise mathematical way to prove it, and we'll need to describe the size of each set. That's what this lesson covers. Let's get the formal definition and see what disjoint actually looks like. So disjoint sets are two sets that have no element in common. 0 overlap, none at all. Compare these two cases on screen. A equals 1, 2, 3 and B equals 4, 5, 6. They are completely separate, nothing shared, disjoint. Now we have C equals 1, 2, 3 and D equals 3, 4, 5. They share the element 3, so not disjoint. So one shared element is all it takes to break disjointness. Do we see the difference? Good. So now we're going to turn that visual idea into a proper mathematical test. Okay? So the test is this. Find the intersection, the set of everything that appears in both A and B. If that intersection is empty, then the sets are what? Disjoint. But if that intersection contains even one element, okay, if it contains even one element, then they are not disjoint. That's it. So we are checking A intersection B equals empty. It is mathematically identical to asking, do they share anything? Do they have anything in common? So the empty intersection is your proof. Are you with me so far? So here's a step-by-step method to apply that test every time. Okay, so 1, list all the elements of A. Okay, then list all elements of B. Then what do you do next? You check each element of what? A, to see if this element is also in B. Therefore, you write the A intersection B equals those shared elements, or empty if what? None. Okay, then 5, you conclude if what? A intersection B equals empty, disjoint. If not, not disjoint. So 2 important rules, okay? 1, shared element is enough to prove not disjoint. But to prove they are disjoint, you must check every element of A. There are no shortcuts here. Okay, now let's bring in the second concept, cardinality. So cardinality is simply the number of elements in a set. We write it as what? N, this way. You're looking at the elements here, or some textbooks also write it as this, right? So you're looking at the number of elements in set A. All right, so let's look at the example here. So here we have A equals 2, 4, 6. It has 3 elements. So the number of elements in set A equals 3. For B, we have A, B, C, D, E. That's 5 elements. So the cardinality here is 5. And C, empty. So what's the cardinality? 0, right? 0. So that's 0. So most of the time, it really is just counting. But there are a few traps, and the next slide covers them all. So watch carefully here. Cardinality has 3 common pitfalls that trip students up. Okay. First, repeated elements. X equals 1, 2, 2, 3, 3, 3. Sets don't count duplicate. So technically, X equals 1, 2, 3. So the number of elements in here, 3 and not 6. Do we get that? All right. Y has 1, 2, 3, then 4. So the set 2, 3 is counting as what? 1 element. So here the cardinality will be what? 3 and not 4. Got it? 3. Let's look at this. Z equals what? Empty. but we are seeing the empty set put what? In a set. So it contains that empty symbol we see as an element, right? And not just left as what? So if this was left as Z equals this, we get that, right? It has nothing in there. But here we put that notation for empty inside here. So it means it contains this notation here, this thing here. This is its element. It's just what? 1, okay? Do we get this? Okay, so the rule is count each comma separated item between the outermost brackets as one element. Got it? Now let's see how cardinality and disjointness work together. So cardinality tells you how big each set is. Disjointness tells you how the set relates to each other. Used together, you can give a complete description. Example, A equals 1, 3, 5. B equals 2, 4, 6. So the number of elements in A equals 3. That of B equals 3. Good. So you're looking at the A intersection B. We have A to be 1, 3, 5, B 2, 4, 6. The intersection here is what? 0. There's no intersection whatsoever. So empty, right? Good. So the full statement that we are seeing here is A and B are disjoint sets, each with cardinality 3. That one sentence tells you everything about size and relationship. Does that click? All right, let's apply both concepts in a worked example. This one has a nice twist. So P equals prime numbers less than 10, and E equals even numbers less than 10. Are P and E disjoint? Are P and E disjoint? So we are going to list our what? Prime numbers less than 10. So set P, prime numbers less than 10. So we have what? 1 is not. 2, 3, you know prime numbers, right? They are divisible by what? 1 and themselves. 7, 9 is not 1. And E equals even numbers less than 10. Even, so from 2, 4, 6, 8, less than 10. So we can add 10 to it. So we have our P and our E. Are they disjoint? So we are going to check for common elements. 2, 2, pass. 3, none. 5, and 7, none. So they have 2 what? In common, right? So 2 is in what? E. And because of that, P and E are not disjoint. Okay. So let's look at it here. Right. So after listing our P and our E, we realize that they have 2 in common. So having 2 in common alone tells us that what? Oh, that rule of disjointness has been broken, right? It has violated it because they are sharing 2 in common. So that means that there's an intersection, and the intersection is 2. It's not empty. Do we get that? Yes. So one shared element, that's all it ever takes. Let's look at the next example. So here, A equals letters in mathematics, right? And B equals letters in physics. So let's look at A and then B. So A, remember, we are not dealing with repetition here. So A will be M, A, C, H, E, M already here, A already here, T, then I, C, S. Don't tell me this is mathematics. Those are just the elements in what? In the letter mathematics, the word mathematics. Then B, physics. We have P, H, Y, S. Do we have I already? No, I. Then C. But we have S already. So physics. Yeah, physics. Okay, so we've listed them out. Now determine if A and B are disjoint. So M, no. A, no. T, no. H, yeah, we found H to be common. So we just stop right there, right? So H is there. Then there are others. There are others like what? I and C and S. But H alone being there tells us that what? They have what? Shared element. So then we know that what? They are not disjoint. So then we find the intersection being H, I, C, S. So math and physics turn out to have quite a lot in common. even at the letter level, right? So that's it right here. We see the set for A, mathematics, and that for B, physics. Remember, physics, we don't repeat, okay? We are ignoring the duplicates. So we see what they have in common, all right? Let's look at worked out example 3. So here we have 3 sets. A equals 1, 2, 3, 4, B 5, 6, 7, and C equals 4, 5, 6. We're looking at which pairs are disjoint, which are not. Then we justify each answer. So A, 1, 2, 3, 4. So let's look at A and B. Then we look at A and C. Then we look at B and C. So A and B, 1, 2, 3, 4, 5, 6, 7. They have nothing in common. So that's empty. A and C, we have 1, 2, 3, 4. We have 4. So they have 4 as their what? What they share. Notice how we didn't put curly brackets here. Okay. Then B and C, 5, 6, 7, 5, 6. So they have 5 and 6 in common. So we can tell that A and B are disjoint sets. A and C are not disjoint. They have 4 in common. And B and C are not disjoint. They have 5 and 6 in common. So do we see that here? A and B disjoint, no common element. But for A and C, we found 4, right, to be the shared element. And then for B and C, 5, 6 to be the shared element. All right. So let's see where these ideas show up outside the class. All right, so these are mistakes that they are worth calling out. Okay, first, disjoint means different sizes. It is wrong. Disjoint is about the overlap, not the size. So if A equals 1, 2, and B equals 3, 4, they are the same size, but they are what? Disjoint, because they don't have any shared element. So disjoint is about overlap. Second, if they share only one element, they are almost disjoint. There's no almost. Okay, one shared element means not disjoint, full stop, period. Do you get that? Third, writing n as what? 1, 2, 3 equals 3. Cardinality is a number, it's not a set. Okay, so n, then you open your curly bracket 1, 2, 3.
Pass easy.
No braces. Do we get that? Just the number 3. Okay, so 3 clean rules, lock them in. Let's wrap up with the full